When a person is out of balance, it often means he or she rotates around 1 foot away from vertical. What force is exerting the torque that makes an out of balance person rotate? So let me draw down here. We've sort of looked at the progression from perfectly symmetrically in balance, shifted weight but still in balance, balancing on 1 foot, which is getting more unstable. But when the person is totally out of balance, so like let's say somebody pushed this person, right? What might it look like? They're kind of falling over now. Here's their other foot in the air, right? And obviously this person is out of balance. Their center of mass point is not over their base of support. But the new concept that we can kind of apply from this chapter to this situation, because before we said, hey, center of mass outside of support base or not over the support base, clearly out of balance. But what really is happening? Well, we have said that the force of gravity can be imagined as applying at the center of gravity. And we've argued that in uniform gravity, that is at the center of mass point. In other words, there's a force here like this, right? So that's that force of gravity on this person. If I take this foot as the rotation axis, then the force of gravity, it turns out, has a moment arm corresponding to the distance from that foot. And so really that means, so that's that moment arm R right there. So that means that force of gravity is actually applying a torque to make this person rotate. So that's really what makes them out of balance, right? That's what's going to make them fall, in other words. So let's check the answer. It says gravity applied at the person's center of mass. I mean, I think that's a little bit simpler than the answer I gave, but the question was really only asking what is the force that is exerting the torque that makes an out of balance person rotate. So I think that's adequate therefore.